Okay, this is lesson 4.2, triangles, congruence by side, 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 and side angle side. Now I've got some folks going, what's up with this? Yesterday in section 4.1, y'all learned that you had to have all 6 parts, 3 sides, 3 angles congruent. Today I'm telling you, you got shortcuts. And today's the shortcuts of side, 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 and side angle side. Okay, so that's what we've got going on. My shortcuts side, 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 and side angle side. So we're learning about that. Okay, so we got to prove 2 triangles congruent, use side, 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 and side angle side. Get those down, and you got to keep in mind what's going on with it. The two are different, and one of them, all 3 sides have to be congruent. One triangle to all 3 sides, and that's enough. Okay, and that's enough. That's all I need. Okay, so now before we even start though, I want to review distance formula. You guys remember using this? It's your favorite thing. Everybody, I get faces, all sorts of mixed faces, from happy all the ways to doom and gloom and everything in between when I see them. But you got to keep in mind what we're doing here when we're doing distance formula. We're looking at this, and you've got the formula D is equal to y sub 2 minus y sub 1 quantity squared plus x sub 2 minus x sub 1 quantity squared. And we're going to add those together and take their square root. And I'm asking you to find the distance between point A and point B here. A couple things are going to come up. First, to find the distance between 2 points, I can mush those 2 letters together like this, and that describes to the person looking at this, I'm looking at the distance from A to B. Okay? Now, I have an equation that I'm going to work with. Okay? And based on this information that I've got, I'm just going to plug these things in. Now, I've got to get the y's together and my x's together. And I know you've seen it as x sub 2, y sub 2, like x sub 2 first and then y sub 2. It really doesn't matter. Matter of fact, I'm going to show you it doesn't. I know I did it this way, but I could. This should be exactly the same answer if I did it this way. Okay. I always have people freak out every year when I flip them around or one thing or another. What's significant about this formula is that I find the difference of the x's, I find the difference of the y's, I square them both, and I add them together and take the square root of that sum. And that's it. That's really it in a nutshell. So let's see how we do with this. So I'm going to take 2a. 2, let's at least put my y's there and there. And then I've got my 7 and it's negative 8 there. So I got my y's different and my x is different. Okay. Who's done it this way before? Nobody? Everybody's looking at me like, can't believe Bloom's writing it down that way. Well, keep in mind, I got 2 minus a negative 8, and I got 8 minus 7, excuse me. So I've got my y's together, and I got my x's together, and I'm finding their difference. Okay. And this is always positive. I always add them together. Okay. So now after I get that, I get 1 squared plus 10 squared is a square root of 101, which is what, 10.04 or something like that? Anybody got a calculator? Got it going? 10.04. Wow, cool. Y'all okay with that value? All I want you to do, I don't care which version of the formula you use, it's the same there. So we're just going to write it down as you got AB. Go ahead and use this one since, you know, I did the other one. Find the difference of the y's, find the difference of the x's, square them both, and then add them together. Go. It's your turn. Figure it out. Okay, so we're going to just plug things in. And I got my x's, negative 4 minus a 6 squared. I got my y's, -2 minus a -5 squared. And I've got these going on. Yeah. Nope. That's why I'm trying to put in on it. It really doesn't matter because it doesn't matter what I added 4 plus 5 or 5 plus 4. It'll be the same value. And we're still finding that same result in each case. It's just one was first and one was second. Okay, so now I've got this. I've got -10 squared, and I've got my 3 squared, and it looks like I've got 109, okay, when I'm done. And I find the square root of that and what that's going to be on my calculator. Someone's got it out there. And then 10.4. So I got 10.4. We happy with that? Do you guys recall doing that? We're going to be doing it today. All right, that's why I went over it. We're going to be practicing it. But before we get there, let's talk about the first shortcut. Our first triangle congruence shortcut. Side, side, side. So essential understanding, you can prove two triangles congruent without having to show all corresponding parts are congruent, okay? So we can do that. Postulate 4.1, side, 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 congruence. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. And that's it. If I've got 3 sides that correspond to 3 other sides and they're congruent, respectively, I've got it made. The triangles are congruent. How do we use it? Well, let's get down to it. I got a proof. Think about it, really? What's the first thing I write in a proof? Given. Get the given down. 1. LM is congruent to NP. LP is congruent to NM. That is given. Okay? The only thing we don't have is this side. What do we know about that side? How could we prove that side's congruent to, I suppose, that side? Reflexive. And that's it. But now here's the thing. This is going to be the first time, I think, that you see me flip the letters. Maybe the second time. Did you guys flip the letters earlier on you? Okay, good. Phew. Okay, so when we're looking at this, let's check this out. Step 2. I know that LN is congruent to NL, and I just might have freaked some people out, but I want to point out to this. Do you see LN? L and N correspond, so LN correspond. NL correspond, NL correspond. So I got to make sure I represent that that's the segment I'm working with. But this is by reflexive property. And it's of congruence, but you know, it's a reflexive property. Do I have all 3 sides of one triangle congruent, respectively, all 3 sides of another? Yeah, I'm done. 3. Triangle LMN is congruent to triangle NPL because of side, side, side congruence. And that's fact, Jack. Yesterday we learned about definition of congruent polygons. All parts of those polygons got to be proven congruent and able for the polygons to be congruent. But if there are shortcuts, and in triangles there are, we can find about them. I've got this next one. And here's the thing about this next one. They're pretty similar, okay? So similar, I want you to do this next one. Go, see what it is. I'm just going to tell you the truth. You got 3 steps. Get after it. You got 3 steps. Get after it. Well, I hope it went well, but let's see how it's going. We got my given. Okay, that should be pretty much straight up. go up and visit the picture after you get your given down. I got that, I got that, I got that, I got that. Gosh, you know, it'd be really cool if I could prove that congruent to itself, wouldn't it? Because then I could use side, side, side. Oh, wait, I can. That's that R thing. You see it in the mirror, right? Reflective, reflexive. It's Halloween, so Mr. Bloom's face, no. 2, reflexive, BD. Now, check it out. Do you see how this is a single to a double? Single to a double. I am not changing the order because it's in a kite or diamond shape, so I put it this way, BD. And this is reflexive property. And it's of congruence because it's property of congruence. How do I know? I'm using congruence signs like that. Okay. Now, based on this information that we have collected, I've got to just evaluate. Do I have all 3 sides of one triangle congruent to all 3 sides of the other? Oh, I got enough. I got the 2 triangles congruent. So step 3, triangle BCD is congruent to triangle BFD because of side, side, side congruence. And that's a fact, Jack. Got her done. Okay. Not so bad. Not as bad as yesterday. Yesterday, oh, those were long. Okay. But is it making better sense now? I got a lot of head bobbles here in class. I hope you got head bobbles at home. By the way, if you're head bobbling at home, you're talking to your computer. We have a little confusing concerns about that. But, you know, go ahead, agree with your computer as much as you want. If it's talking to you, just let it go in the conversation. All right. Next thing, how do we use this thing in other things? Okay, we have this thing, use the distance formula to determine whether ABC, triangle ABC and triangle DEF are congruent and justify your answer. So here's the deal, this is what we're gonna do. You're gonna find AB, then you're gonna find BC, then you're gonna find AC. Okay, that's triangle 1. So get after it. I always have people go, I can't believe 2 minus 2 squared, that's 2 minus 2 squared, plus 9 minus 4. 9 minus 4, quantity squared. I got that 0 squared plus 5 squared. Well, that's 25, square root of 25, which is just 5. Huh, okay, that wasn't so bad, right? Let's do the next one. So BC, do BC. BC would be BC, 2 minus 5, because my x's, okay, plus my y's, 4 minus 4. Oh, hey, that's nice. That's going to be 0 as well. And that's going to be 3 squared, which is 9, plus 0. Oh, it's just 3. Phew, this is kind of fun. These are quick, right? They're way faster than what everybody stared at. So AC, okay, AC. Just make sure I do A and I do C. I got 2 and 5. 2 minus 5 squared plus 9 minus 4. 9 minus 4 squared. I got negative 3, quantity squared, plus 5 squared. I got me 9 plus 25, and that's just going to be the square root of 34. Now, I'm fully aware I can plop that into a calculator, but what's my purpose here? I want to find out if the lengths have the same value, and whether I put it in the calculator and do the square root of 34, or if I leave it as the square root of 34, I would know, right? So I'm just going to go and find the lengths of the other triangle. The other triangle? Yeah, I got to go DE, EF, and DF in a similar fashion. And I'm just asking you all to do this one on your own. Go ahead and get it done. Ta-da! Okay, welcome back. They're all done because you're supposed to do them on your own. But if we look this over, I know that AB is congruent to DE because these have the same measure. I know that BC is congruent to EF because these have the same measure. And I know that AC is congruent to DF because these have the same measures. All right? Those are facts that we can't get around, right? So I know that those two triangles, so triangle ABC is congruent to triangle DEF because of side, side, side congruence. Because I've got all those facts to back me up. And that's where we're going. Okay? Now, keep in mind, this is today. Side, side, side. We're working with side, 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 reflexive property, vertical angles, writing congruent statements and getting things done. All right, we'll see where things going. And just like the other ones, we've got at the end of our notes, if I really do have it, I thought I had it, check the inside part of your front page and just check off the things you know today. Okay, while I'm handing out the assignment. Thanks.